they are all large-scale production systems. So when you look at the tooling landscape in monitoring and MLOps, it's pretty overwhelming. There's a lot happening. So that's why I broke it down from my personal experience to see what's like the 80% solution that you can do. So I will walk you through basic software monitoring for those of you who maybe not backend engineers, and how to add ML monitoring on top, and how you can achieve that using relatively simple tooling. Okay, so let's start with a simple backend monitoring, just to recap. So it's very typical that you will have incidents. So even Google and Amazon, they have health dashboards, and they do even these with these very advanced software practices. They have incidents and they have problems that affect their customers and slowdowns. So the lesson we can all take away here is that you will have problems, you will have incidents in production, and the goal can never be to fully avoid these. There will always be human error, there will be bugs. So the goal is that you are able to detect them and you act relatively fast based on the severity that you find. So okay, cool. So what can you do for the backend monitoring? There's established guidelines from site reliability engineering. So what we typically do is we take the 4 golden signals, which is latency, so how fast do you serve a request, traffic, the total number of requests, errors, so do you have 400 or 500 errors, and saturation, so CPU high as a lead up to the problems that follow. So this means we want to focus on end user pain and impact, not necessarily causes. So you can monitor a lot of alerts and then you wonder like, this and this is high, is this really a problem? But if you focus on these symptom-based alerts, that means actually your customer is currently experiencing a problem, and that's why it's more clear that this is a bad signal, so you should act on it. And I recommend that you use this for all your products. So how does it look in practice? You put these in metrics and you put them on a dashboard, and you can see over time, and then you can set thresholds. And just to quickly walk you through that for those of you who have more of a data science background, so you have some, for example, this is how you do this with CloudWatch. So you have a metric and then you say, if this metric falls below a certain point, I want to be notified. Maybe you get an email or an SMS alert. But there are a bunch of other tools. You can pick some of the tools you have or pick with your favorite cloud provider. Okay, so given that you have the basic backend monitoring covered, what do you need to add on top for ML? So here's a screenshot from the Google paper ML test scores that shows you that if you have an ML application, you add a bunch of complexity on top. So you have the data which is coming in, so you can do data monitoring, you can have skew tests, there you have the model itself, and you have the tests for the ML infrastructure. So this shows you the complexity is higher. So why does that matter? This means there's a bunch of bugs that can happen in production that are really bad and not covered by traditional monitoring. So I gave you some examples from my personal experience in the last years. So for example, we had cases where the client that was calling us had a unit change. So maybe they sent you an integer and they changed the unit from milliseconds to seconds. That's actually happened with the Zalando fraud model. And suddenly your model gets a regular input, it's an integer, but the model gives really weird predictions, and this caused a lot of fraud to get through and was not caught in production. Another example, we migrated to an external article service, which was different, and the fields were differently filled. They had some data loss at migration. Another example where things can go wrong are aggressive post-filtering rules that are applied. For example, someone applies a really bad rule and doesn't notice, so the service will still respond normally, right? With 200s, you will have some articles, but the quality can be a lot worse. So these are silent failures. You can have automated retraining and your model is worse. We had a case where we didn't pin a TensorFlow version and we got a faulty version, but still gave responses, but the numbers didn't make any sense. So basically you can go through the whole list. It's just an example of things that actually are silent errors. They don't cause slowdown, they don't cause errors. but they can have a big monetary impact and a big user impact in terms of usability on your product. That motivates why you need additional monitoring to the backend monitor. Okay, so now that we are hopefully convinced that we need additional monitoring, let's talk about what we can do. I brought you a practical example from my current job. So here we're doing process cost optimizations for loan applications. So a customer requests on a comparison website a loan, I want a new car. Can I get 30,000? And we're like, okay, the comparison website sends that to 30 banks in the background, and all the banks call the credit bureau. And this is pretty expensive. These people have a monopoly and charge heftily for each request. So what we want to do is we want to know if maybe the customer will be rejected, and if this customer has a really high probability to be rejected, we want to reject them early and not make this very expensive call. Okay, so this practical examples, what is the input? So we have some data from the last months, we have the application data, and the process data, your current risk configuration, past applications from the same person, and some other fields, the platform they came from, etc. So what do we actually do with this now? Okay, so this is what I propose as a priority. We take a leaf out of the book from site reliability engineering and focus on impact-based metrics. So we work backwards from the output. So in this case, the priority 1, so let's say the request comes in, and on the left side you see the input data, then you calculate some features, the model gives a prediction, and then maybe there are some post-processing rules and the service gives an output, and then maybe you calculate evaluation metrics and production on it. And if you have all these possibilities, and a lot of vendors now tell you, you need to monitor your input data, and I'm making the case you should start as a priority 1 with monitoring on the right-hand side, so very close to the customer impact. So what does that actually mean? When we talk about evaluation metrics and production, that's usually when people's eyes glaze over. It's like, evaluation metrics and production, what does it actually mean? It means sometimes you're getting the ground truth, but it's a little bit delayed. So let's say you have a service that can predict fraud, and a few weeks later, or maybe a week later, you know if it was actually fraud. So in this case, you have the ground truth if you're letting this person through. It's just very delayed. So this is the first example. So you can have, maybe you have this ground truth, but it could be delayed. So fraud, if you let someone through, it could be delayed. If you reject fraud, of course, then it's unknown. Delayed, another example for a delayed result would be a food delivery service. You say your food will be there in 1 hour and it took 40 minutes, then you know you made an error of the difference between 40 minutes and 1 hour. And then you can also have, maybe you don't have the target close in time because you have a filter bubble effect. We have that in recommendations a lot. So if you recommend 5 articles, you don't know if maybe another 5 articles would be better, because you never observed the customer's reaction to the other 5 articles. So sometimes you have the target close enough in time, and in these cases you can calculate the evaluation metrics in production. So I just gave you a bunch of examples where it might be a bit delayed, but it's still good to calculate. So if you have the food delivery service, you have it maybe an hour later after your prediction. This means it's not perfect for real-time monitoring, but you have the ground truth. So you should have automated monitoring on this comparison. It's really good. So you store the prediction and the target, then you calculate the same evaluation metrics that you calculate during training. For example, you can have a batch job, or you can have an endpoint that you call, receive a feedback call. And then what you do is you put it on a metric and you create an alert. So in our case, with a loan rejection prediction, if we reject a person because, let's say, you want 30,000 for your cool new car, and we look at your credit report, it's like, yeah, no. Then we would reject you, but we would never know if the model did the correct prediction. So what we do is we take a small percentage of the traffic and let these people always through as sort of a live test set. And on these people, we calculate the evaluation metrics in production, and we make a dashboard where we compare the expected performance against the actual performance. So this is the dashboard. So we have live quality metric on that holdout set, the people we always let through. I also know from some colleagues in fraud that they do the same. So some fraud prediction cases, you let a really small percentage of the fraud through just to make sure your model works correctly. Otherwise, you could reject, right? You could reject 90%, claim it's fraud, and if you never actually test if it's actually fraud, you never understand if this model at some point in time started to be not accurate. So here, this way, we have a live test set and we can alert on it. Another priority one signal that I would recommend is stakeholder fear signals. So sometimes when you work with business stakeholders, they're actually not only happy about the potential of your machine learning model, they're also very worried about potential downsides. So what I usually do when I work with a client, I ask them, what are potential risks you see, what are scenarios you definitely want to avoid, and I put these metrics also on a dashboard. Sometimes they say things like, for example, for the loan rejection, they obviously wanted us to not reject customers that would have been accepted. So we have this live test set. They feared that they would make the application very slow. So we added an alert on latency that you would normally also have. But we also have another use case where we automatically scan invoices, and they're very worried about us losing an invoice, for example, permanently corrupted data. So you need to think of a fallback, want to know how often it happens. So things like this that are more from a business perspective are very useful to think of in machine learning, because we're always thinking about the happy case, but it's like unit testing. You want to think of the unhappy case and also make sure that your stakeholder doesn't alert you on the unhappy case that you notice. Okay, cool. Second priority is service response and model predictions monitoring. So what is important to know if you're coming from the machine learning area, that there is a difference between metrics you use to evaluate your model, doing the learning and evaluation, and the metrics that you use for monitoring your machine learning model. So the typical learning metrics, you all know them, precision, recall, ranking metrics, and they're often not available in production, or maybe they're not available close in time. So they are available, but with a delay. So what we need is additional metrics that help us to detect a problem, but it's quite important to get that right in your head. They're not about capturing model quality. They're just proxies that go down when there is a problem, but they're not like absolute metrics that completely have to capture how your model is doing, because that's what we have in training, and it's kind of a mindset shift to think of they're more like indicators. So what can you do? For example, I typically recommend, since the ground truth is very often delayed, that you monitor the output distribution. So often the distribution is a score, a number. For example, you do the output's a score when you do a classification or multi-class classification. And this is a really good catch-all technique because it's real time, and you can, it's easy to do, and you can detect slow or sudden shifts in the response distribution. And it's pretty clear that if something in this response distribution changed, that it changed for your customer downstream. So it satisfies our criteria. We want to know if something changed for the customer. And how can you actually do that? You can start quite simple. You can do rule-based distance metrics like the median, quantiles, share of empty outputs. But you can also get more fancy with statistical distance metrics, population stability index, for example. But you get quite far with these rule-based metrics when you start. So this is what Google uses. It's from their paper, Data Validation for Machine Learning from 2019. And their data testing system, it's basically a histogram comparison. So you have the first time frame, which is the white histogram, and then you have the second time frame, which is the black bars, and then you calculate just the difference in the probability density function. And this is quite hacky, a heuristic, but it works well enough. So basically, you can think of it if the first bar is the amount of people earning between 0 and 1,000 euros, and the second bar is between 1,000 and 1,500, something like this. If shares in this, these buckets change, it means that in this case the input data changes, but you could do it as well as for your model output. In this case it would be model output scores that you bucket and you compare the bucket size. Okay, a next thing that is very useful to do is a human understandable heuristic. So I'm coming from recommender systems, and I was once on a talk of the Spotify people, and they have a personalized homepage ranking, and they said that they have a heuristic that checks for each personalized algorithm the rank of your most used box. So if you always click on 80s pop in the morning, and they have a personalized homepage ranking, your favorite most used box should probably not be ranked very low. That would be a bad personalization if the box that you always click on for your music would be ranked low. It's a great heuristic. It doesn't cover the overall performance of this personalizer, but if this suddenly drops or is very bad on a A/B test, probably it's an indicator that something is wrong with this algorithm. So it's a good idea to have some common sense heuristics for your business case. And as I said, they don't have to be great quality indicators, they just have to go down if the quality goes down. In recommendation, I had something like the share of personalized responses. If it's a personalized use case, that was also a great quality indicator. And I also had a heuristic for bad responses, which was the share of empty responses or fallbacks. Okay, and then I have priority 3, which would be monitoring of your input data and calculated features. You can do it exactly the same as I said before on the statistical tests. So you can, priority 1, that maybe is an exception, is compare the difference between training and serving before you start. There's usually a difference. And then what you can do is you compare the serving distribution over time. So if you have a sudden shift, it can also indicate a problem. The same rules apply. You can use medians, quantiles, share of empty inputs, and statistical different metrics on single fields. This area is still under active research. Very difficult to make good data alerts, but not too many good false positives. And sometimes the input data also changes, but the data science team doesn't care. So I give a practical example. We have an NLP solution that does email routing. And when the app team releases a new feature and maybe the customer has questions about it or doesn't understand, then they start writing a bunch of questions to the email support. I don't understand this, I locked myself out or whatever. The model still gives correct responses, it's routing to the correct team, but the actual input distribution did change. The customer are now writing about something else. But does the data science team need to know and do something about this? No. So there's also a risk that maybe the input distribution changes, but no engineer needs to do anything about this. So it's very tricky with the input data to understand if you even would care if the input data changed, if the model is an acceptable result. That's why I usually start from the output and only look at the input data monitoring if the output changed, more like to help debugging. Okay, so how do you practically implement this? So there's a bunch of nice and monitoring tools. And I did a survey under practitioners in our ML operations community Slack, how many people are using these things in production. And it looks like adoption is not quite there yet. Many of these tools are also still new, so the jury is out. And so what I actually recommend at the moment is that if your company is on the right-hand side, so it means you already have a backend team and you already have some services that you use for monitoring of your normal backend stuff. For example, you have Grafana or you have Prometheus, something for scheduling and polling, that probably you don't need a custom monitoring solution at this point. However, if you have a pure data science product and you start from scratch or you're already really advanced in your monitoring needs, then you can evaluate a more full-featured monitoring platform. So if you don't need to have a custom platform. You can actually immediately start with what you already have. And that's usually sufficient, I would say, in 80–90% of the cases. And you have the advantage that you can integrate these ML monitoring metrics on the same dashboard than your current backend monitoring, which is very good for, for debugging and running in production. And how do you practically do it? So I gave one example about a metric. So a metric, for those of you who are not from application development, is basically a snippet in your code, where as soon as this code is reached, for example, we increase a counter or we add to a histogram. So in this case, it's this example code here where you have a histogram in your code and you call your model.predict, and the model returns your score, and then you increase this histogram by the score. And then you have a second solution that either calls an API endpoint in the service every 15 seconds, what's the current value of this histogram, or what you can also do is you can log away your predictions to S3 and run a simple batch job every 10 minutes that collects these predictions and calculates the histogram and then pushes to a database maybe where you do your alerting. So you can really be quite basic about it and have really good 80–90% monitoring. The important thing is that you automate it and that you create a dashboard and alerts. So takeaway, you have to monitor the 4 golden signals from site reliability engineering, and you add some machine learning on top. And you should prioritize the output metrics and start there. And you add response monitoring, and if you have it, the available evaluation metrics in production. You don't even need a new tool often. You can do it with what you already have, and you add a few metrics. Okay, cool, that's it. We're also hiring. And I recommend you join the MLOps Slack channel. It's quite nice. There are a few practitioners which are really cool.
Thanks a lot, Lina, for the interesting talk. So who wants to start with questions? There were lots of insights, so maybe we want some follow-ups.
Thank you for a very interesting talk. I want to ask more, not technical, like psychological question. The problem with the ML metrics, sometimes what the management does not understand the necessity of this. If you don't have insights and you never seen how it goes wrong, it's like why we need to dedicate time to doing something which is not directly benefiting the customer. So what is your insights, how you sell it, let's say, to the management?
Difficult. I mean, I think as a whole field, we have to practice basic baselines. Now, for example, with site reliability, alerting, and all of this, no backend engineer has to sell their basic monitoring. Yeah, I think it's, I don't know, it's difficult. The heuristics might help. So if you can tell we have a personalized algorithm, but actually currently only 50% have a personalized response, or we have 10% fallbacks. I have many horror stories, but I think on the cultural change on who owns the machine learning debugging, who owns the quality, I have yet to found like the silver bullet answer. I have a lot of technical answers. This sort of how to advance the field, I'm not quite sure on yet.
Okay. Yeah, thanks for the interesting talk. So my question is, when you're talking about monitoring machine learning models, one cannot overlook the concept of data drift. And the question is that in your slides, what concept does correspond to actually data drift?
So, for example, if you have evaluation metrics in production and it becomes slower, like worse over time, at some point you surpass a certain level. Let's say your precision is typically at 90% and then it decreases over time. That's a slow drift, and then you know, okay, now we arrived at 85 and now I need to retrain. That would be drift.
Yeah, at some point you said that, for example, maybe the customer changes the metric from second to millisecond. And can we say that this will lead to data drift?
No, that's not a drift. That is, I would consider that a bug. And I can tell you from experience that, let's say, 90% of all the problems are not data drift, data shift, the customer, whatever. It's bugs. Yes.
Oh,
yeah.
Thanks. Good to know. Thank you.
Yeah, I think that's very interesting because all the communication in the machine learning area is about like your data is drifting and the customer behavior is shifting. You figure that out pretty fast. You retrain every n days or something, that this problem is solved. But this other stuff is detecting mostly bugs, which are plenty. Like in backend engineering.
Hi. First of all, great talk. Regarding slide 20, if I remember right, I wonder how do you deal with seasonality and the amount of metrics that you want to show on a dashboard in terms of defining the threshold for alerting.
Yeah,
I mean,
that
what
is indeed a
counted
problem.
as a bad drift for a specific feature, and if you have tens of models and hundreds of features, these dashboards will be enormous. I just can't
that's
imagine.
why, that's the nice thing. If you monitor the output, you normally have just one output, like one score, maybe the score of the highest classification, you know, the class with the highest score. That's a nice thing. If you monitor the output, not only are you close to the custom impact, you're also not having 150 graphs to look at. And seasonality, that is a problem if you have a seasonality output. But the nice thing about monitoring metrics or heuristics is they don't often have a seasonality. So if you have a precision, hopefully that doesn't vary with seasonality. Your inputs will vary with seasonality, but your output won't. And your heuristic hopefully won't. If you do have it, then you need a better detection algorithm. Then you maybe don't have it as a simple threshold. Maybe then you need to actually fit something. But luckily, I have seen a lot of metrics that are output-related metrics, which are actually don't have any seasonality.
Hey, great talk. Thanks for the talk first. And second, my question is if you have examples of, you are mentioning that you are monitoring output, and that's awesome, because it's one thing. Do you have examples of metrics where you are seeing impact later on, in the sense of, I don't know, bottom of the funnel metrics where you're seeing actual results in a week? For instance, in recommender systems, you might show stuff on Monday and have purchases in the weekend. And you might be in production with models that are not that good for a week. Did you have such cases in your experience?
Yeah, we had, like, for example, when someone applies a business rule which is bad, the nice thing if you monitor, it's a funnel, right? So you could monitor click rates and you could monitor buy rates, but these get very noisy. Not only are they hard to get back technical, you have different front ends and so on. You don't get them in real time when you make a change. You don't get them by A/B test like you can do in your back end. So when you monitor the response, so not after your model, but after all business rules, exactly when you return, then you can see small changes like 15% less filled in these heuristics. And these were actually really good to detect these kinds of problems. The heuristics worked really well.
A very nice talk. I would like to ask, because this is a bank, and my experience and knowledge of the field is that this is very slow moving, very conservative moving field in any technology for two different reasons. The one is culture. We're a bank, we make money, we want to continue to do that. And the other is regulatory constraints. And I would like to understand how you can tackle the data literacy on the one side, and the other is like how you can enforce compliance with all the different crazy regulation exists.
So one thing is how you pick the projects. So regulation mostly applies to anything that you want to take on, so loans you take on. So this project is helping us reduce costs, but the incoming loans, how they're scored, this is not touched. It's basically a shortcut to reject early to save some costs, but we're not touching, let's say, the customer scoring model. That would take years till it goes through regulation. So we're staying really far away from anything to do with regulatory areas and try to help customer service and maybe some areas that don't have regulated use cases. That's one case. And data literacy and that stuff, yeah, is also a problem. We're trying to find, allies in the company, onboard some people, so some of the analysts can do more interesting things than some of the risk people. But it's a slower moving target, definitely, yeah.
And I have a question. So once you kind of build these monitoring tools, how many people have to work on those tools, or they work only on the alerts? So like after you build it, there should be someone responsible.
Yeah.
And so like, it's the data scientist or like from the business, but also like, because it's also capacity there somehow.
Yeah, that's true. So in our case, we have a platform team that operates the Kubernetes cluster and also operates the Prometheus and Grafana. But you can get some of these tools, you can also get hosted at the big cloud providers. You don't have to have your own Prometheus. I think you have it, buy it as a hosted solution. So depending on what you have available as skill set in your team and people working on that, you can look at different solutions, buy it, host it, don't host it yourself.
If someone has very quick question.
Maybe just additionally, can you give some examples of heuristic quality metrics additionally to the Spotify example one?
Yeah.
Especially maybe for recommender systems, it would be
Yeah, in recommender system, I took, we had a logic that had try the first model with filters, try the second model with filters, and so on, and you can fill it up, try fallbacks. So I had a heuristic that said how many of our cases have at least 4 articles from the first model configuration, and how many had fallbacks. Then you have like a traffic light system, which are green from the first configuration, and then red is like a fallback. You can consider a fallback always bad. I mean, sure, you show top sellers, but if the box set for you, or if it's supposed to show similar items, if you in 5% show everybody the same thing on every page, that's bad. So unfortunately, for heuristics are always business case dependent. So you have to look at your business case and pick something reasonable.
Yeah, we are out of time, so save your questions for the coffee break and reach out to Lina. Thanks a lot once more for your practical suggestions, and one more time, big round of applause.